So this is what I had mentioned yesterday about the nature of roots, and therefore, since b square minus 4ac is called the discriminant, we write d is equal to b square minus 4ac. Okay, or delta is equal to b square minus 4ac. Okay. So now we'll discuss some of the rules of the quadratic equation. How to determine the nature of the roots. So you have rule number 1. If d is greater than or equal to 0, then the roots are real. We can definitely say that the roots are real if d is greater than or equal to 0. Okay. Second rule is that if d is greater than 0 only, okay, if d is greater than 0, then we say that the roots are real and unequal. Okay, roots are real and unequal. This is rule number 2. Rule number 3, very important rule, which you will come across in many of the sums, is that if d is equal to 0, what if the discriminant vanishes? Then the roots are real and equal. Real and equal. Okay. And finally, rule number 4 is that if d is negative, less than 0, then we say that the roots are not real or we sometimes say the roots are complex. Okay, whether we say not real or complex, it's the same thing. Now, what do you mean by complex? Complex number we'll just discuss briefly later on if we come across that kind of a situation. Okay, but just remember these 4 rules for the time being. As far as rational and irrational roots are concerned, we will not require rational and irrational roots for your syllabus. Maybe in class 11 and 12 when you will be going, then maybe you will come across rational and irrational roots. But for the time being, we'll stick to these 4 rules. Okay, so now once we have these rules in place, okay, now we shall discuss. I had sent you the notes yesterday of this exercise, but along with this, the notes that I have sent you, you will write those. But apart from those problems, you will also be writing this problem here. Okay, just this is a preliminary set of problems that I'll be doing. Okay, please write this problem also in your exercise copy apart from the notes. Okay, so let us start with this. This is exercise 5.4. I'm going to write the problem here for your convenience. Okay, you locate the problem number in your textbook. Discuss the nature of roots of the following equations. Now, what do you mean by discuss? Discuss means what type of roots, whether they are real, whether real and unequal, whether they are equal, unequal. Okay, that is what you want to check. And these are the equations that are given to you. First is x square minus 4x minus 1 equal to 0. Second equation is 3x square minus 2x plus 1/3 equal to 0. Third is 3x square minus 4 root 3x plus 4 equal to 0. Fourth one is x square minus half x plus 4 equal to 0. Fifth one is minus 2x square plus x plus 1 equal to 0. And the sixth one is 2 root 3x square minus 5x plus root 3 equal to 0. Okay, these are the equations that we'll take up and check what kind of roots they have. What is the nature of roots? So let us take the first equation. The given equation is x square minus 4x minus 1 equal to 0. So compare with the general form. Here, what do you get? Here the coefficient of x square is 1, so a must be equal to 1. Okay, coefficient of x is minus 4, so b must be equal to minus 4. And the coefficient and the constant term here is minus 1, so c must be equal to minus 1. Now we shall check the sign of the discriminant. So therefore, d equal to b square minus 4ac. Put the values. Okay, so this becomes 16 plus 4 equal to 20. So you see that d is greater than 0 clearly. So which rule is applicable here? If you see all the 4 rules, rule number 2 is applicable here. So what can you say? The roots of this equation are real and unequal. Hence, the roots are real and unequal. Any questions on this? No questions? Fine, we'll proceed to the next one. The given equation is, let me write here only instead of writing all over again. Let us take up the second equation. The given equation here is 3x square minus 2x plus 1/3 is equal to 0. Okay, this is already in the form ax square plus bx plus c. So coefficient of x square here is 3, so a must be equal to 3. Coefficient of x is minus 2, so b is minus 2, and the coefficient of the constant term in fact here is 1/3, so c is equal to 1/3. So now we'll put it in the discriminant and check the sign of the discriminant. B square minus 4 into a into c, which is equal to, see this 3 will cancel. You will ultimately get 4 minus 4, which is equal to 0. So what you see here is that the discriminant is vanishing. So therefore, this is a very important case, as I told you. This is rule number 3. Okay, the roots are real and equal. So we say the roots, hence the roots are real and
equal.
Fine. So I don't think this is quite easy. It shouldn't be a problem. Let us proceed to the third one. Third one here, the given equation is 3x square minus 4 root 3x plus 4 equal to 0. Coefficient of x square here is 3, so a must be equal to 3. Coefficient of b is minus 4 root 3. Coefficient of x in fact is minus 4 root 3, so b must be equal to minus 4 root 3. And the constant term here is plus 4, so c must be equal to plus 4. Now put the values here. So this is b square minus 4 into A into C. So this is minus is raised to a even power, so it will become positive. You will be only be left 4 square into root 3 square minus this is 4 into 3 12, 12 into 4 is 48. So this is 16 into 3 minus 48, which is 48 minus 48, which is equal to 0. So again the discriminant vanishes. So we say that the roots are real and equal. Okay. Now, before proceeding further, I would just like to mark these two questions with a star. Okay. Because these two we have found real and equal. I'll just show you something very interesting. If you know that the roots of a quadratic equation are real and equal, then there is something interesting, very interesting observation you can make from the equation. Okay, that I'll show you after I finish all the 6 parts. So let us proceed with the next part. So here the given equation is x square minus half x plus 4 equal to 0. So clearly the coefficient of x square is 1, the coefficient of x is minus half, and the coefficient and the constant term is plus 4. Put it here in the discriminant, b square minus 4 into a into c. So this is 1/4 minus 16. Now we'll not simplify this, because what you see here is 1/4 minus 16 is definitely negative. Whatever negative number we get, 1/4 minus 16 is definitely negative, right? So we are just bothered about the sign of the discriminant, right? We don't actually want the value of this discriminant. We only want the sign. So we know that we are getting discriminant as negative. So therefore, which rule will apply here? Rule number 4 will apply. That is, if d is less than 0,
They're
then the
not
roots
real or
are not
complex.
real or complex. So the roots are not real. Simply say not real, or you can also say complex. Okay? Complex roots.
Sir, we will write complex in bracket or not real or complex.
What?
Sir, we will write the complex in bracket.
No need.
Or
Only
we
not.
have to
Even
give.
if you write not real, will do.
Okay, sir.
Okay. So the next problem we take up is the 5th one. Okay, so if you see 5th one carefully, you will see that a is minus 2, b is 1, and c is 1. Put it here, b square minus 4 into a into c, which is equal to 1 plus 8, which is equal to 9, which is greater than 0, right? So we say that the roots are real and unequal. But there is something very interesting that you see. I told you that I won't discuss, but I mean, since I see a 9 here, I'm just tempted to mention this. Okay. See, 9 is a perfect square, right? Note. You see that d is equal to 9 is a perfect square, isn't it? 9 is 3 square. It's a perfect square. In this case, we say the roots are real, rational, and unequal. Understood? So you can write real, rational, unequal, but this is not required for you. You simply write real and unequal, that will do for you. Okay. So this is just a small note that I made for you. Next, number 6. In fact, in the later classes, you will see that this is actually a root, the rational roots. Let's say next equation we take up. The next equation is 2 root 3x square minus 5x plus root 3. equal to 0. Coefficient of x square is 2 root 3, so a must be equal to 2 root 3. Coefficient of b is -5, and the coefficient of c is, and the constant term is root 3. Just put it here. So b square minus 5 square minus 4 into a is 2 root 3 and c is root 3. So you put it here, you get 25 minus 5 square is 25 minus 4 into 2 into root 3 is 3. You get 25 minus what's 24, which is equal to 1, which is greater than 0. We say roots are real and unequal. Can we say that the roots are rational? Yes. Can anyone tell me whether we can say that the roots are
No,
rational?
sir.
Why?
No, sir.
Why?
Sir, because 1 is not a perfect square.
Why is 1
Sir,
not a
because
perfect
1 is
square?
not a perfect square.
1 is equal to 1 square. Here d is
Sir,
equal
because
to
1 is
1.
the smallest
1
number
is a
of square.
perfect square. 1 is equal to 1 square. So the roots are rational also. Real, rational, and unequal. Okay. No questions on all these? Not only unequal, but real, rational, and unequal. Okay. So if you don't have any questions in this, then we can proceed to 2 more problems from the textbook, which I have not given you in your notes, but you are expected to write these. Okay. So let us do these 2 problems. In my textbook, the number is 42. So you just check with what number is there in your textbook. I'll just write the question. Find the value of p for which the equation x square plus p minus 3 x plus p equal to 0 has equal roots. Okay, now I had marked this 2 questions as with a star mark, no? So I'll just discuss and then come back to this problem. Okay, now you see that these 2 problems that I have marked with star, okay, these 2 I had just we just saw that these 2 had equal roots. Now remember, whenever an equation has equal roots, the left hand side of the equation can always be expressed as a perfect square. Okay, so let me just write it here. We'll come to the solution of this problem a little later. Note, whenever we see that a quadratic equation has equal roots, the left hand side of the equation must be a perfect square. Must be a perfect square. Now how? We'll see here. Consider this example. Consider those 2 equations in as shown above. As shown above, this equation 3x square minus 2x plus 1/3. 3x square minus 2x plus 1/3 equal to 0 has equal roots, right? So therefore, we start with this. Therefore, 3x square minus 2x plus 1/3 is equal to 0. Now I'll show you that 3x square minus 2x plus 1/3 is nothing but a perfect square. What I do is I divide both sides by 3. Why do I divide both sides by 3? Because I want to make the coefficient of this x square as 1. So I divide both sides by 3 to get x square minus 2/3 plus 1 by 9 equal to 0. Dividing both sides by 3 to make the coefficient of x square as 1. Okay. Now see. Back in class 8, if you remember, this is something that we discussed in factorization. Even in class 9, I think a little bit I discussed. See, this is my a squared term, right? And this is my b squared term. What is my b squared term? 1/3 square, because 1/9 is 1/3. A square is nothing but x square, right? So I get a square here, and I get a plus b square here. What about 2ab? Let's see whether we are getting 2ab. 2a here is x, and b here is 1/3. Yes, we are getting 2ab also. So therefore, this is not plus, this is in fact a minus sign here. As above, we maintain this sign. The sign is a minus sign, so we maintain this sign here. So this means this is what form? A minus b whole square form. So this is x minus 1/3 whole square equal to 0. That means x is equal to x minus 1/3 equal to 0. That means x is equal to 1/3. Now you'll say that we are getting only one solution. As I told you last year also, even if you're getting one solution, because it is a quadratic equation, they are equal roots, right? So the roots of the equation, the roots of the quadratic are 1/3, 1/3. Equal roots, two equal roots. Okay, although you're getting one value of x, but still since the roots are equal, there are two roots, 1/3 and 1/3. Any questions on this? Consider the next one. As shown above, what is this one that I have marked here? Yes, 3x square minus 4 root 3 x plus 4 equal to 0. This is the quadratic. As shown above, this has equal roots, right? This has equal roots. Now, that means this can be expressed as a perfect square. So we have the left-hand side of this equation can be expressed as a perfect square. So we start from the equation. We want to make the coefficient of x square as 1, so we divide both sides by 3. Okay. Dividing both sides by 3. Next, see that this is my a square term, right? Now b square term, although it does not look like a perfect square, what we can do is we can write 4 by 3 as 2 by root 3 whole square, isn't it? So this becomes my b square term. Now let's check whether we are getting the 2ab term. Minus twice a is x and b is 2 by root 3. Are we getting? Yes, we are getting. We are getting 4x by root 3. But here if you see, I have a root 3 by 3, isn't it? So what we do is we just do an additional step, and then we can express it as a perfect square. Additional step is what? We cancel in the middle term in this, we cancel root 3 from the numerator and the denominator. So minus 4 root 3 divided by 3, we write as root 3 into root 3 plus 4 by 3. And this is x here. There is x here also. So, and this we write as 4 by 3 equal to 0. So now 1 root 3 cancels from here. So what we get here is x square minus 4x by root 3 plus 4 by 3. Now the question here is, have we got yet? Now you'll see we have got. This is my a square term, right? This is my b square term, and minus 2ab term, twice a is x and b is 2 by root 3. Now are we getting? Yes, now we are getting. So therefore, now this is a minus b whole square form. So x minus 2 by root 3 whole square equal to 0. That means x is equal to x minus 2 by root 3 is equal to 0. That means x must be equal to 2 by 3. Okay. So for convenience sake, you can rationalize the denominator and write this as 2 root 3 by 3. Because later on, who knows, you might be asked to find out the roots up to 2 decimal places. So this will be convenient to work with. Therefore, the roots are 2 root 3 by 3, 2 root 3 by 3. That's it. Any questions on this part? If not, then I can move to that problem that I have left. No questions? And let us move on to that part that we had started, that problem that we had started. Okay. One problem here and one more problem on the next day I'll discuss. And then you can proceed with your notes. Then I can explain the notes to you from the next class. So this was our problem. The question was, find the value of p such that this equation has equal roots. So we start by saying the given equation is x square plus p plus 3x plus p is equal to 0. And we call this 1. Since it is given to you that 1 has equal roots, since 1 has equal roots, discriminant must be equal to 0. So let us find out what d is. So here d is equal to, okay, let's first write down the values of a, b, and c. Then we'll find out this. So here we have, what is the coefficient of x square? 1. What is the coefficient of x? It is p plus 3. And what is the constant term here? P. So therefore, what is the discriminant here? Discriminant here is b square. Let's write the discriminant first here. Discriminant is equal to b square minus 4ac, which is equal to b square here is p plus 3 whole square minus 4 into a into c. Okay, let us simplify this. So expand this by a plus b whole square formula, p square plus 6p plus 9 minus 4. So you get p square plus 2p plus 9. Isn't it? This is what we are getting. Yes. Right. So now, since 1 has equal roots, so here d must be equal to 0. Right. This is p minus 3. I'm sorry. This was not p plus 3. This was p minus 3. That's why this was all p minus 3. So b was p minus 3 given to you. Okay. So that when you're finding out the discriminant, this becomes p minus 3 whole square for b square and minus 4ac term you have. So this becomes minus 6p. So minus 6 and minus 4 combined to give you a minus 10p. Okay. So that is what you're getting. Since b is equal to, now since the roots are equal, as I said that it is given to you that the roots are equal, that means you know that the discriminant must be equal to 0. So we start by the fact that discriminant must be equal to 0. So that means you have p square minus 10p plus 9 is equal to 0. So now this is also a quadratic which you can easily solve by factorization. Minus 9p minus p plus 9 is equal to 0. That means p into p minus 9 minus 1 into p minus 9 is equal to 0. That means p minus 9 into p minus 1 must be equal to 0. That means either p is equal to 9 or p is equal to 1. So only for these two values, when here in this equation, when p is equal to 9 or when p is equal to 1, 9 or 1, only then the resulting equation will have equal roots. Otherwise, you cannot say. But definitely if p is equal to 9 or p is equal to 1, then you can definitely say that the roots will have equal roots. Fine. Any question? No question, then I'll stop here for today.